Hello everybody. In today's video, we are going to learn how to integrate a function using the concept of limit. We all have studied how to differentiate a function using limits using first principle, but here we are going to learn how to integrate a function using limits. For your recall, I want to state the first principle, which says that the derivative of any function is equals to limits h tending towards 0 f of a plus h minus f of a upon h. Okay, now I think you can understand, but here today we are going to learn how to integrate a function using limits. This process is known as limit of sum. For this we need some prerequisite which I would like to tell you earlier. AP, you all know what is a AP. A plus D, A plus 2D is a series which has a common difference, A plus n minus 1 into D. So sum of n terms of AP we all know that is n by 2, 2A plus n minus 1 into D. Similar thing goes for a GP. You all know what is a GP. GP is a sequence which has common ratio. Okay, so sum of n terms of a GP is equals to first term into common ratio raised to the power n minus 1 upon r minus 1. Okay, so these are some prerequisites we will require to solve the problems. Now let us get to know what is the formula. The main formula for the limit of sum is integration of any function, let's say f of x, with respect to dx from a to b is equals to limit h tending towards 0 h f of a plus f of a plus h plus f of a plus 2h up to f of a plus n minus 1 into h, where h equals to b minus a upon n and n tends towards infinity. Okay, since n tends towards infinity, to h tends towards 0. Same, understand? We can also say that nh equals to b minus a. So this is the formula for the limit of sum. So let us take an example. We will require to integrate a function x plus 1 from 0 to 5. So here we can see that f of x equals to x plus 1. So using our formula we get to see that limit equals to limit h tending towards 0 h f of a is 0. Understand? F of a plus h will be 0 plus h, f of 0 plus 2h, okay, up to f of 0 plus n minus 1 into h. Understand? So using this in our function we get h. F of 0 will be 0 plus 1, which will be 1. F of h will be h plus 1. F of 2h plus 1. Understanding now? Up to n minus 1 into h plus 1, since this is f of n minus 1 into h. So putting this n minus 1 into h plus 1, we will get this one. Okay, now repeating same things, h. Here we can see that 1 goes from 1 up to n minus 1. Since we have n minus 1 terms having 1, so adding those all we will get n minus 1 times 1. Okay, and we are left with h plus 2h plus 3h up to n minus 1h. Okay, so limit h tends towards 0, h, this will become n minus 1 plus 1 will be n, plus this is, see, this is a AP now, and sum of AP is n by 2, where n is the number of terms, but since we have here number of terms equals to n minus 1, we will write n minus 1 by 2, and 2a, a will be h plus n minus 1 by 2. Since upper n is equals to n minus 1, that's why we'll use n minus 2, n minus 1 into d, and d is equals to here h. Understanding now? Which will be equals to limit h tending towards 0, h n plus n minus 1 by 2 into 2h plus nh minus 2h. 2h gets cancelled, which we are left with limit h tending towards 0, h n plus n minus 1 by 2 into nh. Since I have said earlier that we have get h equals to b minus a by n. Here b is 5, a is 0, which gives 5 minus 0 by n, and from here we will get nh equals to 5. Understanding now? So using that nh equals to 5, here we will get h n plus n minus 1 by 2 into 5, which is equals to limit h tends towards 0, h n plus 5n by 2 minus 5 by 2. Now again limit h tending towards 0. Now multiplying all the terms, nh, 5nh by 2 minus 5h by 2. Since h tends towards 0, therefore 5h by 2 tends towards 0, and nh equals to 5. Here this one, nh equals to 5. Using that here also we will get nh equals to 5 plus 5 into 5 by 2, which is equals to 35 by 2. This is the answer. Now to recheck our answer, we can also simply integrate the function using the concept of integration, which will be equals to x square by 2 plus x from 0 to 5, which will give 25 by 2 plus 5 minus 0, which will be equals to 35 by 2. Since both are equal, that's why this is the answer using limit of sum. Let's do one more problem. E raised to the power x dx from minus 1 to 1. Okay, now using our formula, we will have limit h tending towards 0, h f of a is minus 1 plus f of minus 1 plus h plus f of minus 1 plus 2h up to f of minus 1 plus n minus 1 into h. Okay now, and let's calculate h equals to here b minus a by n. B is 1 minus minus 1 by n, which is equals to 2 by n. Okay, now f of minus 1 will be e raised to the power minus 1. F of minus 1 plus h will be e raised to the power minus 1 plus h. F of minus 1 plus 2h will be e raised to the power minus 1 plus 2h. Okay, that goes to e raised to the power minus 1 plus n minus 1 into h. Understand? Limit h tending towards 0, h, and let's take common e raised to the power minus 1 from the whole here. Okay, we will left with e raised to the power 0 plus e raised to the power h plus e raised to the power 2h up to e raised to the power n minus 1 into h. You don't know how to take common from exponential functions. We will take common e raised to minus 1, then it will get subtracted from here and all the exponents. Okay, now repeating same thing, tends towards 0, h by e. I will write e minus 1, e raised to power minus 1 by 1 upon e. Okay, now see, this is a GP now. since it is a common ratio, e raised to the power h, and it is a GP. Now we will all study that the sum of GP is a. So this is a GP which has n terms, n minus 1 here, plus adding this we will get n terms. So sum of GP is a into r raised to the power n minus 1 upon r minus 1. So using that, this will be multiplied, okay, and e raised to the power h upon e raised to the power h minus 1. Look, I will write it next here, okay, that will be better. H tends towards 0, h by e raised to the power 0 multiplied by e raised to the power h raised to the power n minus 1 upon e raised to the power h minus 1. Okay, understand now? I will told you Sn for GP is a r raised to the power n minus 1 upon r minus 1. Since we have r equals to e raised to the power h here, that's why we are writing this, and a equals to e raised to the power, that's why we are writing this. Okay, now I think you will understand it more clearly. Okay, so here we will get h by e raised to the power 0 is simply 1, and e raised to the power nh minus 1 upon e raised to the power h minus 1. Understand now? That will be limit h tending towards 0. What about, I will write this h in the denominator, no problem now? Here it will be e raised to the power nh minus 1 upon e raised to the power h minus 1, and this h on numerator I am going to take it in denominator like this. Okay, no problem. Since we have also the formula for limit h tending towards 0, e raised to the power h minus 1 upon h equals to 1. So applying this one here, we will get limit h tending towards 0, 1 upon e raised to the power nh minus 1. Now from here we will have nh equals to 2. Understand now? So using that here, we will get limit h tending towards 0, 1 upon e raised to the power 2 minus 1, okay, which will be simply e square minus 1 upon e. That will be our answer. Okay, so recheck it. Minus 1 1 e raised to the power x dx is equals to e raised to the power x minus 1 to 1, which will be equals to e raised to the power 1 minus e raised to the power minus 1, which will be e raised to the power minus 1 1 1 e raised to the power 1 minus 1 upon e, which will be equals to e square minus 1. Done. Both are equal. You can see it, e raised to the power 1 2 minus 1 e raised to the power 2 minus 1 upon e. So our answer is, so that will be the end of our today's video. Like it, share it, subscribe it. Thank you.